Welcome to our Vision Campus. Let's assume you want to create an autonomous self-driving lawnmower. The spatial orientation of the mower should be directed by cameras that scan the environment. As you learned from our previous video, what is embedded vision? A classic machine vision setup wouldn't be an option. However, this is a perfect example for an embedded vision application. Why? The mower's power supply comes from batteries. The power consumption of the system must be as low as possible. We want the mower to be small, so we have space constraints which do not allow integrating a relatively big PC. We want to sell the mower in high numbers. Low production costs are essential. So how can we realize the setup for our mower? Small size is achieved by a small embedded processing platform which uses a system on a chip, in short SoC. An SoC is an electronic component which contains the core elements of a computer. Its built-in graphics processing unit is especially well suited for vision tasks. Further, there are a CPU, internal buses, interfaces, etc., all on a single chip. Although a typical SoC is not as powerful as a comparable PC processor, the performance of an SoC is good enough for many applications. To ensure a low-cost design, the SoC is soldered directly onto a small printed circuit board which contains all the electronic parts necessary for our mower. How do you integrate vision into your embedded setup? A boxed camera would be too big, too expensive, and would also consume too much power. A good option would be a camera module, a board-level camera. This kind of camera is reduced to only the parts needed for your application. For example, we don't need a housing, because the camera will be directly integrated into the mower. This saves space, power consumption, and most importantly, costs. How can the camera module be connected to our processing board? Camera modules come with various interfaces. The most common ones are USB 2, USB 3, proprietary parallel or serial interfaces, or MIPI CSI2. Each has its pros and cons. USB 2 is quite often already available on many SoCs. This means that only minimal additional hardware, for example the USB connector, is needed to connect the camera to the SoC. The disadvantage of this interface is its low bandwidth, of only up to 40 megabytes per second, which makes it impossible to run high-resolution sensors at higher speed. With up to 360 megabytes per second, USB 3 provides much more bandwidth than USB 2. If the modules support the USB 3 Vision standard, their integration is easy. Drivers and camera SDKs, for example Linux ARM-based embedded systems, are standardized and normally run without problem on such systems. The plug-and-play nature of USB makes it very easy to integrate such modules into the embedded application. If development costs need to be under tight control, USB can be a good choice. Both USB 2 and USB 3 have one thing in common: they need relatively big connectors and have less flexible cables, which might conflict with the strict space constraints of some applications. However, only a few high-end SoCs have USB 3 interfaces available. Some camera modules come with proprietary parallel interfaces. They are typically connected via flat flex cables to the processing board. Such modules require an SoC with a parallel video input, which is available on only a few SoCs. The maximum possible cable length is typically limited to 50 centimeters. Camera modules with proprietary serial interfaces are mainly designed to be connected to a field programmable gate array, in short FPGA. If the core of an embedded setup is an FPGA already, this interface can be a good choice. These modules are also connected via flat flex cable to the FPGA. Some module vendors allow cable length of more than 1 meter. Both the proprietary serial and proprietary parallel interfaces have in common the importance of making sure that a camera driver for the targeted camera and SoC combination is actually available. MIPI CSI2 is a very attractive interface, standardized by the Mobile Industry Processor Interface Alliance. CSI2 stands for Camera Serial Interface Second Generation. It is the most common interface for mobile applications, and it is used for connecting a smartphone's camera module to an SoC. Almost all SoCs provide up to 6 serial lanes, which can be used to connect one or more cameras. Each lane on its own provides a bandwidth of up to 300 megabytes per second. Even high-resolution camera modules can be operated at high speed. The cable length, however, is limited to less than 30 centimeters. Again, it is essential that a driver for the targeted camera-SoC combination is available. Otherwise, extra development efforts must be spent for developing the driver and software stack. This can be very time-consuming and costly. For a good overview, see the pros and cons of the different interfaces in the table. As no additional hardware is required, and the cable length doesn't matter in our MOA example, CSI2 can help to implement extremely cost-effective, high-performance applications. So for our MOA, the MIPI CSI2 interface is precisely the right interface. Enjoy your free time while your lawnmower is cutting the grass. Thanks for watching.